how many number of moles of each of the components are remaining in the system. That also we have to identify now. Xi equal to 1 means all the A would have become into product. That means no A is left out in the system. So number of moles of A is 0. 100% converted. Okay. Now total number of moles of R formed is it should be equal to 1 because stoichiometry says that 4 moles of A is giving us 1 mole of R. Like that 4 mole of A is giving us 6 mole of S. So 4 is giving us 1. Now the same 4 is giving us 6. The basis also we have taken as 4 moles of feed mixture. This feed contains only component A. That means this 4 moles of A should give only 1 mole of R because this is from stoichiometry. This reference I am taking it from stoichiometry. So from stoichiometry we observe that 4 moles of A is giving us 1 mole of R and then 1 mole of 6 mole of S. So the same value we can take as a reference value even for that column also. Now total number of moles when Xi equal to 1 is 7. See, with this total number of moles, let us to find what is the expansion factor value. Expansion factor epsilon A is equal to volume at Xi equal to 1 minus volume at Xi equal to 0 divided by volume at Xi equal to 0. It is the fractional change in volume between no conversion and the complete conversion of reactant. That is called expansion factor. So, see, substituting the value in the formula, 7 minus 4 by 4 is equal to 0.75. Now, use this expansion factor here in equation 1. So, equation 1 contains a term called epsilon A. In place of that, this value is now substituted. So, after doing that, let us to take this entire integration, by means of some variable called as I. That is what is shown here in the next step. So, here we can find that we are taking the entire integration as equal to I. So, we would like to find the value of integration separately first. Then later on, we will substitute the value of integration in equation number 1. Okay. Now, this let I is equal to integration of this entire function. Here that is expansion factor value substituted. You can see that epsilon A value is taken as 0.75. Whatever the answer we got here, that is being used in place of the epsilon E. Now, for integration of this function, the function as it is, it is somewhat not integratable form. What we are doing is split the function into 2 fractions. That is, break the function into 2 simpler functions. So, first function becomes as integration of dxa. This dxa is multiplied here. So, dxa by 1 minus xa. Then second function is 0.75 integration of xa dxa divided by 1 minus xa. So, the function is made into 2 simpler functions. That will help us for doing the integration also. Otherwise, the function, if it is kept as it is, means very difficult to integrate it. There is no formula available to integrate the function as it is. We have to go for the graphical method or numerical method to find the integration value. So here, I would like to approach the problem by means of the analytical integration method. So for that, make the function into 2 fractions. That is what is done here. Now, the first part of the fraction, if we see, it is nothing but integration of dxa by 1 minus xa. It is like a standard formula, like integration of dx by 1 minus x. So for that, the result should be minus logarithm of 1 minus x. So this upon integration will give us a minus log of 1 minus xa. So for this, the lower limit is 0 and upper limit is 0.8. So this limiting value we have to apply. Upper limit minus lower limit we have to apply for the result. Now for second case, 0.75 integration. So again, this function is not integratable as it is. So this needs some modification. So what I am suggesting here is, again we have to make the function into a simpler function form so that it can be integratable very easily. So my suggestion is that let us to subtract 1 in numerator and add 1 in numerator. Like this, minus 1 is subtracting minus 1 and then adding 1. So like this, if you do, means the result is not going to be affected. So minus 1 plus 1. So now what we can do is, let us to again split the function into 2 fractions. Like xa minus 1 divided by 1 minus xa, that is made as the first fraction. Second fraction is 1 divided by 1 minus xa. Like that, the Again the entire function is made into two different fractions. So if it is simplified like that, the xa minus 1 by 1 minus xa, this can be cancelled out, which will give us only minus 1 as the result. That means the first function is like a simple function, like a minus integration of minus dxa we are having. Second function is dxa divided by 1 minus xa. So this for this function already we know what is the result also. It is like dx divided by 1 minus x. That will be equal to minus ln of 1 minus x. Now we have to apply the integration formula for all these cases. So for first case already it is done. Upper limit minus lower limit. Lower limit is you get logarithm 1. Logarithm 1 value is 0. Upper limit is logarithm of 1 minus 0.8. So 1 minus 0.8 is 0.2. For this you have to find the logarithmic value, logarithm base e, natural logarithm value. And then here it is integration of minus dxa. So which will give us only minus xa. It's a simple integration only, like integration of dx equal to x. So again here also we have to apply the limit. This is also very simple, like the previous term, very first term what we had. So minus logarithm of 1 minus xa. So we need to apply the limiting value for the resultant all. Upper limit minus lower limit if we apply, and then simplifying the all the numerical terms, so that means we are getting the value of integration as 2.2165. So that is the value of integration for this that is a problem statement. Okay. Now let us to use that I in equation 1, because equation 1 this integration value only we are trying to find it now. This value just now we got it. Okay. Now go back to equation. Actually in equation number 1 there is one more term is also available called as Ca0. So Ca0 is the initial concentration of component A. But nowhere the data is given. Ca0 value is not given anywhere. So separately we have to find, or individually we have to find the value of Ca0 by means of the given data. So for that let us to assume that the gases behave in an ideal manner. So for ideal gases, the equation to be used is Ca0 is equal to Pa0 divided by Rt. So Pa0 is the initial partial pressure, R is the universal gas constant value, T is the reaction temperature. So P0 value is a given data. Then R value is in SI system, the R value should be 8.314 joule per gram mole Kelvin. So temperature value is 922 Kelvin. That is also a given data in problem statement itself. Substituting all the values and simplifying it, we get the value for Ca0. So Ca0 is 60 mole per meter cube. That is the initial concentration of A. Now from equation 1. We have to use this equation 1 to find the value of V. Now that equation 1, we know what is the 10 is the rate constant value, V is the unknown thing, Ca0 is 60 mole per meter cube. Just now we got the answer there also. This Fa0 is the molar feed rate, that is given as 40 moles per hour. Integration value also we got it now, 2.2165. Since all other values are known to you, substitute the known values in the equation 1 and get the value of the volume. That is what is shown here in this calculation. So from equation 1, 10 is substituted, V is unknown, Ca0 is known, 40 is also given data, I now it is obtained here. So use the data here. Then say by cross multiplication of the numerical values and all, we get the volume as 0.1477 meter cube. See now it is made into, say from meter cube it is made into, changed into liter, which is equal to 147.7 liter. So for the desired conversion of 80%, the reactor volume should be almost equal to 147.7 liters we have to use for this reaction. So this is about that. This problem explains the application of the PFR equation, performance equation for a blood flow reactor. So see, you can go through the problem content or the explanation part, everything and all. So any clarification is there means you can ask me. Otherwise, see, thanks for listening to my lecture. So I request you to go through the problem statement as well as the solution step, everything and all in detail. So any clarification, so you can contact me afterwards. Thank you very much.